there are 3 numbers you really care about in base rule, and you can deduct quite a few numbers based on those 3 numbers. First of all is 100%. This is the population. The population is 100%, right? Everything is a portion of this 100%. So it's usually a fraction of this, right? And remember, it was saying 0.01% of the population have cancer. So it's a small percentage affected. And there is a test that exists in this world that can measure whether this person have cancer or not. It will give a positive result or a negative result. And when it's testing, let's say this person have cancer and the test is positive, that's a great news, right? So that's called the sensitivity of the test. It's called sensitivity because it's picking up something that, is wrong about this person. It was accurate. So it's 90% of that 0.01 of that 1%. And there's another way to measure how accurate the test is. It's called specificity. And in specificity, you want to say, if this person does not have cancer, give me a negative, right? I don't want to have a false positive. So it's, in this case, in Udacity's machine learning case, it's saying 90%. So you want to calculate a number of false positives. How do you calculate that? False positive is 1 minus that 90%, right? Because it's saying if you don't have cancer, you should test negative. And 90% of the people achieve that negative result. So what portion achieves the non-negative is 1 minus 90, so 10%. However, this is 10% of the entire population. So it's actually much bigger than the 2 circles we've drawn. So this blue circle is the false positive. 90%, so 90% of that 1% of the population, so 0.01 times 0.9 is 0.009. 0.009, which is 0.9% of the overall population, will be tested positive while having the cancer. So now the next episode will be that we will see a question. Say if you tested, so now that we went to the hospital and got a test, you got the result back. And the result said, yes, positive. You have this type of cancer. Note, even though the test is positive, usually your doctor asks for follow-up because no test is 100% right now. So now that in this world, in this scenario, if you were given a positive test result, now what's your chance of having cancer? It's actually not as high as you think. You were given 3 choices in this question: 90%, 8%, and 1%. So now that you know you're tested positive, so you're either in this purple circle here, or this blue circle we looked at, because you have to test positive first. Only in these 2 circles are you positive, right? So now they want to know, what's your chance of having that cancer now? So what is the question asked? It's really asking the probability of one person having the cancer while testing positive. So the test shows positive, but what's the chance of you having cancer now? This turns out to be a non-trivial answer. We will go over in the next part of our tutorial.